Good morning and welcome everyone. We are a group from BERW1055 and today we'll be presenting our assignment 2 for the subject System Development and Planning under the guidance of our lecturer, Technology Skyra Anwar bin A. Rahman. We hope this presentation will be both informative and engaging for all of you. Before we begin, allow us to introduce ourselves. I am Nurul Ifa binti Azmi, student number B122510694. My teammate is Eliza Nur Anis binti Arifin, B122510709. And our third member is Ainul Mardiah binti Nur Azman, B122510713. Together, we have prepared this assignment to the best of our ability. This assignment focuses on evaluating whether global circuit should replace their existing Defender etching machine with a newer model called the Challenger machine. To make this evaluation, we have applied two main analytical approaches: risk management analysis and project planning analysis. Let me now walk you through the content of our presentation. Our presentation today is divided into two main tasks. Task 3 covers risk management, where we will construct a decision tree and calculate the expected monetary value, also known as EMV. Task 4 covers project planning, where we'll build an activity on node network diagram and apply the critical path method or CPM to determine the project duration and slack. I will now hand over to Eliza to begin with task 3.
Thank you so much, Ifa. My name is Eliza and I will be presenting task 3 on risk management analysis. In this task, Global Circuits is considering investing in the Challenger machine to replace its current Defender machine. However, future market demands is uncertain, meaning there is a possibility of both profit and loss. Therefore, a proper risk analysis must be conducted before any investment decision is made. Based on the case study, two possible market scenarios have been identified. The first scenario is market expansion, which represents a success outcome. The scenario has a probability of 90% and will result in a profit of 80,000 ringgit Malaysia. The second scenario is a market contraction, which represents a failure outcome. This scenario has a probability of 40% and will result in a loss of 20,000 ringgit Malaysia. These two scenarios form the basis of our risk analysis. To visualize the decision-making process, we have constructed a decision tree diagram. The roots of the tree starts with the main decision, whether to invest in the Challenger machine. From the change node, the tree branches into two possible outcomes. The first branch leads to success with a 60% probability and a payoff of positive 80,000 ringgit Malaysia. The second branch leads to failure with 40% probability and a payoff of negative 2,000 ringgit Malaysia. This diagram helps us clearly see the risks and potential returns involved. Next, we calculated the expected monetary value, or we call it as EMV. Using the formula, EMV equals the sum of probability multiplied by payoff for each outcome. The calculation is as follows. First, 0.60 multiplied by 80,000 plus 0.40 multiplied by negative 2,000. This gives us 48,000 minus 8,000, which equals to 40,000 ringgit Malaysia. The EMV for investing in the Challenger machine is therefore 40,000 ringgit Malaysia. Based on our EMV calculation, the investment is financially justified because the EMV value is positive at 40,000 ringgit Malaysia. This means that Global Circuits can expect an average gain of 40,000 ringgit Malaysia after taking into account both the success and failure scenarios. Therefore, we conclude that the company should proceed with investing in the Challenger machine as the expected return is positive. Let's moving on to the task 4, which cover project planning using the critical path method, or we call it as CPM. In this task, our objectives are to construct an activity on node network diagram. determine the critical path, calculate the total project duration, and analyze the total slack for each activity. I will now pass the presentations over to Ainul for the detailed explanation.
Thank you, Eliza. I am Ainul Mardia and I will continue with the project activities and durations. The project consists of 5 activities. Activity A is site preparation and safety setup, which takes 3 days and has no predecessors. Activity B is delivery and inspection of the Challenger machine, which takes 5 days and depends on Activity A. Activity C is electrical and utility connection, which takes 4 days and also depends on Activity A. Activity D is mission installation and celebration, which takes 6 days and can only begin after both B and C are completed. Finally, Activity E is operator training and trial run, which takes 3 days and follows Activity D. Using the activity data, we constructed the activity on node network diagram. The diagram clearly shows the sequence and dependencies of all 5 activities. The critical path for the project is A, then B, then D, and finally E, giving a total project duration of 70 days. The red lines in the diagram represent the critical path, while the dashed lines represent the non-critical path. The forward pass was used to calculate the earliest start and earliest finish for each activity. Activity B start at day 0 and finish at day 3. Activity B start at day 3 and finish at day 8. Activity C start at day 3 and finish at day 7. Activity D start at day 8 and finish at day 40. Activity E start at day 14 and finish at day 17. This confirms the total of project duration is 17 days. The backward pass was then conducted to determine the latest start and latest finish for each activity. Working backward from the end of the project, the results show the activities along the critical path have identical earliest and latest time, meaning there is no room for any delay in those activities. This confirms which activities are truly critical to completing the project on time. The slack analysis reveals the following result. Activities A, B, D, and E all have a total slack of 0, confirming that they lie on the critical path and cannot be delayed without affecting the overall project completion. Activity C, however, has a total slack of 1 day, meaning it can be delayed by up to 1 day without impacting the project deadline. Therefore, the critical path is A to B to D to E, with a total duration of 70 days. I will now hand back to Ifa for the conclusion.
Thank you, Ainul. In conclusion, the project successfully evaluated the replacement of the Defender etching machine with the Challenger machine using 3 analytical approach: financial analysis, risk management, and project planning. From the risk management analysis, the AMV of 40,000 ringgit indicated that the investment is financially viable. From the project planning analysis, the critical path method confirmed that the project can be completed in 70 days. With activity C having a flexibility of 1 day, overall Global Circuit is highly recommended to proceed with the Challenger machine investment. That brings us to the end of our presentation. On behalf of all 3 of us, Nurul Ifa, Eliza, and Ainul, we would like to sincerely thank Technologies Khairul Anwar bin A. Rahman for his guidance and support throughout this assignment. We are now open to any question you may have. Thank you very much for your time and attention.